Since ancient times, human activities have been the largest source of environmental pollution, but pollution was carried out in small scales. However, with the exponential increase in population, there is a considerable increase in human activities, creating more waste production, which must be correctly disposed of and segregated to facilitate recycling and waste management process, as well as to avoid pollution at the environment. Unfortunately, the traditional methods of waste disposal have not been efficient for this purpose, because even with correctly labeled trash, people still throw their trash in wrong place, making the separation process for recycling difficult, compromising the time efficiency and the sustainability of the process. In order to address this problem, we introduce to you the GreenGuard Smart Waste Bin, a revolutionary solution integrating advanced technologies. GreenGuard is not only a waste bin. GreenGuard is an environmental guard, is your friend, and also is a way of teaching people how to behave well when it comes to recycling process. An ultrasonic sensor triggers the lid to open upon detecting waste, making disposal effortless. Our system even rotates container to direct sorted materials to the appropriate compartments. But it's not just about efficiency. We're introducing very revolutionary features as a reward mechanism to incentivize responsibility waste disposal. So, combining advanced technologies and engineering knowledge, we can create a cleaner, healthier environment while minimizing human contact with the waste, protecting yourself and protecting the environment. As urbanization and consumption patterns intensify, waste collection becomes a critical issue, leading to overloaded containers, unhealthy environmental, and increased risk of infection for workers. Currently, safety measures are insufficient, requiring the development of innovative technologies to minimize human contact with the waste and address inefficiencies in traditional waste management process.
Our current waste management systems are struggling due to population growth and urbanization. Traditional methods like overflowing bins and landfills harm the environment and public health. Overflowing bins are common sight, causing unpleasant odors and dirty surroundings and attracting disease-carrying pests. Rising trash production strains existing waste management infrastructure. Traditional collection methods are reactive, leading to overflowing bins before scheduled pickups. Traditional collection methods are inefficient. Sorting leads to mixed waste streams, hindering recycling and increasing landfill burdens. The solution is smart waste bins, because smart waste bins use sensor technology, AI, and real-time data collection to improve waste management. Field-level sensors transmit data, allowing for optimized collection routes. This reduces unnecessary travel, lowers fuels use and emissions, and prevents overflowing bins. AI-powered smart bins analyze waste composition for automated sorting and collection. This significantly improves waste segregation and maximizes recycling rates. GreenGuard goes beyond operational efficiency to offer significant environmental benefits, such as reduced landfill waste. By improving recycling through AI sorting, keeps valuable resources out of landfills. And other impact is lower emissions. By optimized collection routes, decrease fuel use and emissions, promoting a cleaner environment. Our GreenGuard Smart Waste Bin project conducted a survey to understand user needs and gauge interest in its innovative waste management solution. Firstly, for demographic, primarily 61.9% were male respondents and young adults between the age group 18 to 21. Mostly were students, providing a valuable campus-specific insights. By that, 57.1% were aware of existing programs but unclear on effectiveness. 23.8% acknowledged existing programs with a positive view, and 19% were unaware of any current initiatives. This suggests a need for improved awareness or stronger program impact. Towards the GreenGuard Smart Waste Bin perception, a significant interest of 76.2% were curious with a focus on functionality, which is available with the right features. Automatic leads received some support but not the most crucial factor. However, 81% were more likely to use beans with automatic leads. Gamification and rewards emerged as the most popular feature suggestion. And lastly, for the impact on waste habits, the survey explored the potential impact on children's waste disposal habits. A significant portion expressed a willingness to become resource champions. This suggests GreenGuard smart bins can motivate students and promote sustainable practices. However, some respondents suggested a need for additional strategy for broad behavioral change.
So, in this project, I am in charge of doing the design of our product. So to start, I did an early sketch first of the product, and during this stage, we decide the suitable shape of the bin, and after a few suggestions and also a few discussions with the group members, we decide to stick with the cylindrical shape of our recycling bin. And next, we determine the perfect length, width, and also the depth of the product. And I also consider the usability of the design. And last but not least, before finalizing the design, I took some feedbacks from the group members before I finalized the design to ensure the design meets the standards of our group project. So next, after I did the early sketch, I transfer the sketch into the AutoCAD. And during this stage, I execute the design by referring exactly to the early sketch, and I also ensure the dimensions fit perfectly same as the sketch. And lastly, I make an orthographic view of the product. So in the orthographic view, I provide the upper view, the front view, and also the side view of the product, and also put the dimensions aside of it. Next, I also put some labels on it to determine which is the trash divider, the bin flap, and also the power box of the product.
According to Mohd and Manaf 2013, the three major recycling materials are metal, plastic, and paper. Thus, we decided to make GreenGuard to separate these three different types of waste. First, the user will scan the object at the trash bin, and then the compartment will rotate, and then the lid will open so that you can throw the trash in the correct compartment. For scanning, we use an inductive proximity sensor to detect metal and a capacitive proximity sensor to detect non-metals. This is the first step of separating metals from non-metals. For plastic and paper, we simply use a laser and a sensor. For paper, the light will not go through it, and for plastic, the light will go through it. After scanning, then the lid will open automatically for you to throw the trash in. This is because 94% of respondents say that the lid of the bin feels unhygienic, so we make it so that it automatically opens. The main thing about our GreenGuard is its gamification and reward point system. You see, when we do something with a reward, then even if that thing is a hassle to us, we will still do it. Picture when you go to a supermarket and they give you free gifts or free coupons when you spend more. So even though you're using a lot of your money, but since you're getting a reward, then you don't mind it. Another example is Nike Plus, as when you wear the product, you can track the usage of the product through an app, so you feel satisfied when you have done milestones. So GreenGuard will use the same concept when you throw in, and a QR code will pop up on an LED screen. So using this, you can claim your reward. This is to encourage people to do recycling and to use our products more. Now, there may be some health and safety concern of using the GreenGuard. The two major concerns are fire hazard and the sustainability of our power source. For fire hazard, since we are using low power materials, then you don't need to worry about the GreenGuard suddenly combust into flames. And for the power source, we will try to adapt solar power source at strategic bins, or even if we are using a battery powered source, we will make sure that the GreenGuard stays in low saving mode when not in use. This is done by placing a sensor to which only when people want to use the bin, then only will the bin power up. If not, then it will stay in power saving mode. This is to reduce the amount of power usage.
I'm going to proceed with the methodology part. First, I'm going to explain about the flow chart. In this flowchart, we described the operations and activities that have been done this SEM and the ones that will be done for the next SEM. This SEM, we cover from the project initiation until the submission of the proposal. For the second SEM, that is the next SEM, we'll cover the buying of materials, all the operations until the final submission of the final report. Second, I'm going to talk about the identification of the materials and the reasons why we chose those materials. The capacity proximity sensor that is used to detect any near object, the inductive proximity sensor detects the metallic objects, the ultrasonic sensor detects the ultrasonic waves distance, photoresistor detects the changes in light, the PIR motion sensor that detects the motion in infrared radiation, servo that enables the mechanical motion, ESP32 integrates the sensor data, near-infrared sensor emits the infrared light, solar panels to convert the solar energy into electricity, the lasers for the measurement of the difference, Arduino for the measurement of the waste levels, the display to display all the information, and last but not least, the total metal bin that is going to be used as the body of the smart waste bin. Proceeding, I'm going to talk about the justification of the software used. We have the Arduino IDE that is mainly used for the coding part. We have the AutoCAD that is used to design the physical structure of the bin. We have the Microsoft Word that is used for all the documentations of the smart waste bin. We have the Microsoft Excel that is used to analyze data from the cost analysis and the budget. And finally, we have the Google Form that is used for gathering the feedback of the public. For the final part of the methodology, I'm going to talk about the fundamental engineering analysis, in which I'm going to explain what is the engineering behind the smart waste bin. First, I'm going to talk about the electrical and electronic analysis. In this part, we calculated the current flowing through the components using the Ohm's law, in which we divided the voltage by the resistance. And these are the values. After the calculation of the current flowing through the components, we use these values to calculate the power consumption of the smart waste bin. So the total power consumption of the smart bin is calculated and the value is approximately equal to 10 watts. Following the first engineering analysis, we have the second one, that is the mechanical engineering analysis. In this part, we calculated the volume of the smart waste bin. That turns out to be 0.668 meter cube. After that, we used the volume to calculate the maximum mass that can be used in the smart waste bin. Lastly, we calculated the maximum stress that the smart waste bin can support, and the value is 4,174.6 pascals.
And today I will talk about the project managing, planning, and economical and business consideration. This project was orientated and visualized by Dr. Aliyu Sulaimon, with the members that are William Benjamim, who is currently doing chemical engineering and he is our team leader, Asyraf Syazwan, who is doing electrical engineering, Adelaide Albino, and Diocleciana, who are both doing chemical engineering, Haeikal Khairi, who is doing mechanical engineering. This project has a feasibility plan that complies with ISO standards, which adhere to applicable law, including the ISO 14001 and the ISO 9001, which addresses data protection for consumer safety and privacy. This project also evaluates the cost-benefits analysis for success determination, which was estimated to be less than or equal to 300 Malaysian ringgits, and the materials for this project may be found on hardware stores or online, for example, Lazada. This project has an advantage of including eco-friendly and portability for the technical resources and skills. The Smart Bin is focused on two sustainable development goals, the 11th and the 12th goal. It is also an innovation that will attract large population. This project relies on solar power energy for most energy demand, which reduces the cost and carbon footprint, which requires less maintenance on battery charging. The
the production per unit is estimated to be 279.75 Malaysian ringgits with 20% profit margin, which makes a sale price of 335.70 Malaysian ringgit.